I can now hide all geometry in this section. I can hide this axis system. It seems there is a sketch which is open. We'll check on that later. So this is our blade section. And now once again, our blade section is constant. Let me hide this. Our blade section is constant and it runs from here up to this endpoint. So instead of plotting two aerofoils, we are just going to select these two elements and we're going to translate them. The direction is the X component. Up to the end section, so that's the end section. Alternatively, you can maybe check that this length matches the radius of the main rotor, because that was indicated in the document I showed. So if we check on this, right about where we had our drawings, we have this radius. This is 26.4. That is from the center up to the very end. 26.4, that is feet. So in millimeters, it is 1400 millimeters. So that means that, hold on, let me put OK first, that the distance between this center, or no, the center of this circle, the distance between the center of this circle and this end one here is going to be 1400 millimeters. So you can do subtraction. You can measure the distance between this profile and this center, then subtract it from 1400 millimeters, and then you're going to translate this to that remaining distance. In my case, because I'm showing you how to plot this is not going to be my exact model that I'm going to use for analysis. I'm just going to leave it at that. We can use multi-section surfaces to enhance our geometry. We can create a guide, a point-to-point line, starting from that point to this point. Select OK. Then select multi-section surfaces. This is the first geometry. Second profile, sorry, it's a profile, and then the guide is going to be this line. Preview. Select OK. From this diagram, you can see how the blade connects to this section. So it has two teeth, and this section has sort of a three tooth. So to simplify the geometry, we're just going to create a section like that, an open tooth like that, and then it's going to mate with a three tooth from this section. So it's going to be very simple. You can see how it's supporting the entire blade section from here. It extends. We can try to also extend it, maybe create it like that, which comes down like that and like that, or create an upper section and a down section. So we're going to simplify it as much as we can. So we can select our multi-section surface. It don't have to be very boring. Then we have this section. so that we can be able to identify them. Go to side view. So right here we are creating a 3 tooth. We can start on this section. I'm just going to fill. No. We don't have to fill anything. We can use this axis system for this section. So we can sketch on the ZX plane. I'll go to the side view. And from here, select profile. So from about this point, horizontal line that comes down to this point. I'm going to select this translate and project it as a construction element so that I can constrain this line by coincidence. Select profile once more. Then at the middle, we have another section that goes down. Skip. So this doesn't need to be very high up. So we're going to leave room for that section that is coming here. And then I'm also going to select this and project it as a construction element and constrain this line to this using coincidence. Then I can select my entire geometry. Yes, I can select my entire geometry and mirror that using the horizontal plane. Using this horizontal plane. And we've got our first mating geometry. So we exit and then we create the second one. So once again, sketch on this. Sketch here. Go to the side view. And now for this, I'm going to start from about this point. And I can first select sketch 6 and project it right here as a construction element. Okay, we've got that. Select profile. And we're going to start from this point. So it's going close to the other profile, but it's not touching the other profile. Up to the middle section. This is also a standard element. I'm going to make this point, and I need an edge here. So I'm going maybe to select this and project it. Project, this time we cannot project 3D elements. We have to project the silhouette, 3D silhouette edges, so that we can get this edge. Make it a construction element. So that way I can constrain this point to this edge using coincidence. And I can also create, let's pull this one down and inwards. I can create a corner. Like that. And another corner here. Okay, so this surface is smooth, and then we have the tooth. And this tooth actually doesn't need this line. It can just end here. And then what we can do is just complete it from here, or you can join it directly. So to this corner. Like so. Then now I can select everything. And again mirror that using the horizontal axis. Exit the workbench. So we've got those two profiles. I'm going to select Sketch 6, go to the Mechanical Design Pad Design Workbench, and create a pad. It's going to be mirrored on both sides. The length is of course 100. I don't know what it means by self-intersecting. I'll have to check that. Let's check on this. It must be maybe where we created a mirror right here. So just select this and create a connecting line as a standard element, of course. And then check if the problem is resolved. Okay, this applies to the external part as well. sketch number 6, this line as well. Yeah, I can see it's self-intersecting. Can delete that and just complete this line. Now we can create a pad using sketch 6. No. The profile is sketch 6. Okay. So many troubles. Let's hide sketch 7. I hope the integrity of the sketch is now okay. Once again, create a pad. Sketch number 6, mirrored extent. This is going to be 100. I might reduce this because it seems like it's too much. I might reduce. So it's in the part design, pad number 4. Let's try 80. From the image, yeah, it's cutting off a section of it. 60, preview. Okay, 60 looks much better. Now let's show sketch 7. I hope there are no intersecting elements. And instead of creating a pad, I wanted to, yeah, okay, let's first create a pad. Let's create a pad. We can create a pad with mirrored extent. This is our profile. And now instead of 60, we can maybe create 50 so that there is an abstract. 50. We are going to select this bottom surface. This surface. Hold on. Let me hide that. I'm going to select this bottom surface, sketch it. And just create a rectangle. Hold on. You can first project the surface as a construction element, then create a rectangle. So it's not going to cover the entire surface. Just about that point. So that will be the surface that will be clamping onto the body. Okay, then we're going to create a pad up to surface. select this surface. Okay. Select OK. Then that sketch, where is that sketch? That was sketch 7. Nope, 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 nope. That was sketch 8. I'm going to show it. Then select this surface, sketch, and just project sketch 8 as a standard element. Hold on, not the silhouettes. We need to project 3D elements. And repeat the same procedure, just create a pad up to surface, select OK. So now the clamp is completely holding the blade, although not the entire section of it. We can hide this and this. So then you can create 2 sections here. Just sketch on this surface, create circles, one here, which is going to be, say, 10 millimeters in diameter, and another one down below, which is also going to be 10 millimeters in diameter. Then the distance between this and the edge is 30. That is up to the circle, not the center. Same way with this and the edge. Now it's picking the other side, so this has to be 40. Now exit and create pockets up to last. So to create the securing rods, we are going to have to create a profile here. So we're going to switch back to generative shape design and make sure we are still on this geometrical set 1. So define in work object. Then insert a point at the center of a circle and select this edge. Then insert an axis system there. Then you're going to sketch this ZX or ZY plane, either is okay. I'm going to go to side view. And then using profile, but before I do that, I'm going to select this circle, the edge, and then project it as a construction element. Go to the side view. Then create an axis. going to create an axis that is coincident with this point. So select the point and the axis and make it coincident so that it's in the middle. Once we have that, you can create your half profile. So from here, up to about this point. Then it goes down, then to where the whole section begins, and vertically down up to the axis. Then mirror that using the axis and exit. Then revolve. So we are creating solid sections right now, but either way we can still create a surface section because we are going to close all the surface section later on. So select revolve. The revolution axis, it should be this Z plane or the H direction. Select OK. You can now hide the sketch. And then all you have to do is create another axis here. So a point which is at the center of this sphere. Then insert an axis system right here. Then do an axis to axis transfer. This is the element. This is the reference. And this is the target. Select OK. Now you can hide these two axis systems as well as the points. So now you've secured the blade. We can hide this sketch as well. We've now secured the blade. So don't worry about the open profile because, as I said, you're still going to close it using using the close surface option in mechanical design. But if you just want to close it, just select that option, select OK. And voila, you've got a closed section. So we've got one blade. Remember, we are only creating one blade section, and then we are just going to create a circular pattern. So you don't have to worry about creating more blades. Once we are done with one, that's it. Now there is an extruded surface here that connects with this star. So this star is definitely too large. So we're gonna go back to where we were creating this. That was pad 1. Go to the sketch. And now that we have everything, we know that we are connecting it using this circular section. So the axis, let me undo that. We're just going to reduce the size of the axis, the vertical size. If that doesn't work, you can just enter the distance. So the distance between this center and this says it's 347. We can try to make that 200 and see. So 200 we are connecting here. Maybe 150. So that's 150. We can reduce this radius to 20 for all of them. Lastly, we have this one. Okay, so now if it's here, we can create a protruding section here that just joins with this one. So exit. So what we're going to do is we have a section here. We have this XY plane. We're going to use it again. The XY plane. Sketch. So now this one is below. We need to project this as a standard element. And then create a section right here. So create another circle using that center. About that point. Align. That just connects it to this body. And another line. Like so, just a simple structure. Trim off the excess element. Maybe, let's see if we make this two tangent, what will happen. Yeah, tangency like so. This point and this point should be coincident. All right. So we've got that. We can go to mechanical design, pad design, and create a pad. It's okay, it's going to join this mirrored extent, but the limit is going to be narrow. Select OK. And the last thing is a connecting rod. So just back to GSD workbench, create a circle, a point, using the center of a sphere. It should be right here. So if it's not, just undo that. and just make sure that you go to geometrical set 1 and define in work object. Then once again select point using center of sphere, of circle I mean. Select this edge. Okay, insert an axis system. Then sketch the ZY plane or the ZX plane. We can sketch the ZX plane. Okay, this is okay. So we've got a circular section here, which we are going to project as a construction element. And now once we have that, we can create now our section. So profile, start from the center. The same way we did for the other section. Like so. And right here, we're just going to select this one, project it as a construction element. Then constrain this line to this using coincidence. Then the distance of this line, if it's 5, both of them should be 5. So go to the upper side and select this. This should be 5 as well. Lastly, you have this distance. So the distance between this line and this line, it should be 0 or just select coincidence. All right. Exit. And create a revolve surface 360 degrees. The revolution axis is this H direction. Select OK. You can hide the sketch now. And the axis system as well. The point 2. So now we've completed one blade. And now what we are going to do is to select all these surfaces and create a circular pattern. So to create a circular pattern, we need an axis that is at the center of this circle. So we no longer need these two axis systems. Just click on point. Select this section and insert an axis system. Now you're going to create the circular pattern for the surfaces and then for the solid part differently. So for example, this one is a solid part. This one is a solid part. And this one is a solid part. We had pad 7 and pad 8 here. Nope. This was pad 5, sorry, pad 5, pad 6, so all sections that are solid in part, we can create a circular pattern first, and then we go to the other sections. Now, because we are in the GSD workbench, let's actually start with the surfaces. I can hide this. I can hide these points. So insert, operations, advanced surfaces, hold on. Advanced replication tools, we are going to select circular pattern. The instances are going to be 5. The reference object is going to be, now our object to pattern is going to be this. Reference is the Z component. We are going to select a complete crown and select OK. Next is this surface. Insert, circular pattern. Let's deselect this. Object to pattern is going to be this surface. Reference, complete crown, 5 objects, select OK. Object to pattern, I'm going to select all the bolts. Okay. Then the reference element is going to be the Z component, and it's going to be a complete crown. All right. So far, so good. So let's go to the mechanical design workbench and then we pattern this one. Or we can try to pattern them here. But I don't know. I've never tried to pattern solid objects in the GSD workbench. So we can start with, see, it says select a GSD object. So let's just go to the mechanical workbench. Go to part body and define in work object. Insert. Transformation features, then we have circular pattern. Once again, we have a complete crown of 5. Now, the problem here is if you select the current solid, you're going to select everything. So we need to select one object at a time. So instead of current solid, I'm going to select particular pads. Like we have pad 3 using the Z axis. Select OK. Then we move on to so we've got pad 3. We have here pad 4. We've got the Z component, complete crown. Select OK. So it's just I like to do it just a few items at a time, so that in case there is an error, it's easier to rectify. We have pad 5. Once again, here we have the Z component, complete crown. Select OK. I'm going to select pad 6 and okay, let's do pad 6 first. Using the Z component. Cancel. Let's try to select that once again. Let me see. So the inner parts that we created are the ones that I am trying to project. And that is pad 6 and pad 7. Okay. Pad 7, insert a circular pattern. I don't know why it should be a problem to just add pad 7. Okay, let's cancel that. Pad 6. I think it's because no, but we didn't use a symmetry. If we didn't use symmetry, then it should be able to work. Select OK. Okay, let's move on to pad 7. All right. It worked when I did it individually. So lastly, it's this one, the pad 9. And now, as you can see, we've got the complete setup that is even connected down below. You can hide the access system now. And we can go to geometrical set 1 and show revolute 1. So we have this, we can adjust this. pad definition, mirrored extent. I don't know why it's going all the way up if it's up to this point. That is weird. Okay, undo that. I don't understand why it changes its position once we go back to the normal view. But anyways, we can just push it down a little bit if we want. This was, you can hide that point. And now what I want to do, let us hide this first. We can put the blades together, the blade surfaces. So we have circular pattern 1 and multi-section surface 2. Insert. I don't know if there is an option to group together. We have change geometrical set, explode, upgrade, isolate. So I'm just going to say insert geometrical set. And we're going to name this blades, so that it's easier to find. And we can just give it, let's say black. We have that surface. And oh, there's one surface that we did not, and it's this fill section. This fill section, we did not create a circular pattern of it. So we can go back to GSD, insert. Now make sure we are in geometrical set 1. Insert advanced replication tool, circular pattern. Object to pattern is going to be the fill section. Was it this one? Or was it this one? Fill 1. We just hid our axis system, but we know it's the last one. Axis system 6. Select the Z component. It's a complete crown. Select OK. So now all of them are closed. So now we can apply materials. So the parts that are made out of the solid, they are going to be aluminum gray. I can do the same for this one. So if I feel this one is too high, I can cut down on it using part design workbench. We also have the rods. I'm going to use DS black. Close. Don't forget to save your work. So that was the tail section. And the main body. Go to shading with material. And this is what we have. So we've created pretty much all the parts except the skid. That's going to be our last part. The skid is very simple to create. So it's just the main stand. This skid, we're just going to create it on one side and then mirror it on the other side. Very, very simple to make. Once we are done with that, then maybe I can teach you how to split these surfaces so that you can create the windows and the transparent or the translucent parts, as well as some final detailing. Like this one, we have a light here. We have a section that goes inwards here that is dented inwards. And maybe these two instruments. And I think we'll be done with our aircraft. So I'll catch you in the next episode. Let's finish up with the skid.